Today, here at this theater, I will be part of the measurement conference where I will talk a bit about DeWeSoft and their new product, Obsidian.
I use my digital output to drive the motors, so I am finally alive.
That is great. What can you do?
I can measure everything. I am really good at it. You can connect the computer or mobile phone to me and look at the data, but I can also store the data by myself.
How do you control your eyes?
I have in me also the real-time loop which can be used for alarms and controlling motors.
So you can measure and control at the same time?
Yes, but I am still very clumsy. To be able to control my body, I need to learn a lot.
Don't worry, Obsidian, I also have a lot to learn. We will learn together.
So I was improvising. Isn't it awesome?
Hey, this is a serious event. Look at this crowd. It's an opening event of DEWESoft MC2024.
Of course, I know. It's the best event since the last measurement conference, and that's why I made it so impressive.
Right. And now we're back live.
Everybody, welcome. Jake Rosenthal is the regional manager of DeWesoft USA. In Italy, there are much more interesting things to monitor than the bridges. Gabriele, my friend, please join me on the stage and tell us everything about the ancient history. of Tesla.
Thank you, Jure. It's my privilege to kick off this automotive application talk, and I want to say that I really appreciate Jure for asking me to do this. Tesla is not just an automotive company, they're a technology company. When people think of Tesla, they think of the car. They think of the car that's the quickest production car in the world. Sorry for the Italians out there. But when you think about a car, you need to also think about everything that goes into making that.
And don't make me cry, otherwise you will have to do the rest of the presentation. Andrej, thank you very much for the last 25 years. True. And for that, we have prepared a special gift.
Now for Acrobats. For us, Acrobats are the ones that are a bit different, unusual. They're always trying new things, they're always innovating, they're pushing boundaries. We would say they're also geniuses, they're visionaries, and to be honest, they're often misunderstood. And we want to say we do understand them and we want to help them. Because at the end, those are the ones that are innovators who are changing the world for the better. And we call them the Acrobats.
And we are always amazed by the young minds, by the young people who are doing things differently. And we were also amazed by Etto thing. Etto did a lot of videos on measurement technology, published that on social networks. And we are very happy that Etto is today with us. Etto, hello. One question. How come that you got so much interested in measurement technology?
Well, it's from a long time. I have had some interest in STEM technologies, and so I found that measuring how things work is very interesting.
Great. Is there any part of the technology which is really the most interesting for you?
I had an interest in rocketry and aerospace, and quite recently I've developed a new interest for power electronics.
And then you made a bunch of videos. Is there any test which is really close to your heart? Which one would you say that it was really the most fun?
Well, I've had a video where I made the testing of an induction motor, and I found that very interesting as I could measure lots of different things.
Etto, I have another question. Do you know about our new product, OBSIDIAN?
Yes, it's your new embedded data acquisition real-time system.
And today we have news. We actually have prepared a very special demo of OBSIDIAN. We put a bunch of motors together, connected directly to the OBSIDIAN, and then put a sock over it.
Hello.
Hello, Etto.
Obsidian?
Yes, I use my digital output to drive the motors, so I am finally live.
That is great. What can you do?
I can measure everything. I am really good at it. You can connect the computer or mobile phone to me and look at the data, but I can also store the data by myself.
How do you control your eyes?
I have in me also the real-time loop which can be used for alarms and controlling motors.
So you can measure and control at the same time?
Yes, but I am still very clumsy. To be able to control my body, I need to learn a lot.
Don't worry, Obsidian, I also have to learn a lot. We will learn together.
Let me present Niels Redger, the CTO of OpenDaq.
Hey, Jure, isn't this guy from the HBK?
Yes.
Isn't HBK our competitor?
Yes.
And what are we doing together?
We are creating the history. No worries, man. Everything is going to be alright.
Let's verify that the Tesla coil is on with the neon bulb. So it's pretty clear that there is a lot of disturbance on the analog sensor and there is nothing on the MEMS. Of course, it's on fire, so let's hit up the sensors. It will take some time, there is some inertia, of course it's a big aluminum box. Now the temperature is slowly starting to rise.
So this is your thermal camera,
Yes.
and you're measuring it with the DEWESoft X.
Yes, that's our PI 640 with 640 times 480 pixels of resolution, and we have a DeWeSoft plug-in. Yeah, so that's an obvious DeWeSoft plug-in that you connect directly the camera to the DeWeSoft software.
So with this camera you can see the temperature of different things at different distances.
So you can create different areas, and you can figure out the maximum temperature, minimum temperature, or the average temperature. You can choose it, and then you can see it in a numeric or also in a graph what is the temperature in the DeWeSoft or over our camera.
Yeah, so for example here we can see that the maximum temperature is about 40 degrees.
Yeah, the measurement area is hidden in this moment, so I don't know exactly where it is. It's somewhere here in this area, and it could be that we see some other reflection that it shows now.
Yeah, because if you have some metal object, it would reflect light, for example, from the lights, which are...
Yeah. It could be that we have some reflection over metallic surfaces, and then we get not the true values.
Yeah. And for example, these pens have this metal part, and we can see, maybe if I do this, that it seems hotter, the metal part, because it reflects heat from my hand.
Yeah. That's the typical emissivity, the different emissivity of metallic surfaces and the plastic surface. Yeah.
So the metal does not emit as much IR light as the plastic.
Yes, it's reflective, more reflective. The metallic surface is more reflective, and to measure the metallic surface you need short wavelength pyrometers or cameras, so it's another wavelength. Yeah. Instead, for the plastic you need long wavelengths that you can get the right temperature back.
And this is for longer wavelengths?
This camera is for long wavelengths. It works between 8 to 40 micrometers. Yeah? And then you can measure the temperature of all surfaces except glass and metal.
A question, if I go like that with a blowtorch and I turn it on, if I go to the other side of the room with a blowtorch and turn it on, would it be seen here?
Yes, the infrared goes from near to infinity. Yeah, it depends always which lens you use. Yeah, in this case we have a 33-degree angle. Yeah, and then you can calculate or use our optic calculator to see what is the field of view of the 640 times 480 pixels for the certain distance. Yeah, and then you see how big is each pixel.
No, I mean like the blowtorch makes enough IR light to be visible at a great distance.
Yeah, you see it, yeah, but it must be a visible view from the camera to your side. Then I can see you exactly. But we must sharp it. Yeah? From a certain distance, then we have a deep sharpness. Yeah? But when we go nearer, we must sharp the lens that we have a clear infrared picture. You see, now we have it sharp on your face. Yeah, but in the far field, yeah, it's unsharp. Yeah? When you go in this direction and I make the sharpness for this field, then I see in the back side all sharp. Yeah, because then we have a certain deep sharpness.
So how is the measuring conference going for you?
It's very good. There's a lot of people around, everybody excited from the very first day in the theater. I think it's going very nice.
You have the rocket, DeWesoft Italia has built the rocket, and I saw that it's attracting a lot of attention.
Did you see there was a lot of people in front of the rocket? Huh?
Yeah.
Yeah. It was designed by students. We had the summer camp in the last 2 years here in the headquarters. And the students winning the summer camp were working on that rocket, and we paid just the material and all the works done outside, but all the design was done by them in their spare time. It was very great. It's a nice tool for conferences and exhibitions.
So it was designed even by students from other countries?
No, it was done actually by the Italian students that were it's a local Italian project. Yeah.
Well, unfortunately, you couldn't make many rounds of smoke because of the fire alarm.
Yeah, we tried at the beginning and the firemen were not happy and we decided, we were asked not to do it anymore. I guess there will be a launch tomorrow, right after the keynote. So stay tuned.
So this is the rocket that you have made with a couple of other students.
Yeah, correct. Basically, I work with 3 other people on the mechanical part and with a girl for the design of the livery. So basically, this is a demo toy that we produce for DeWeSoft. We can make 15 measurements with it. There is an electric motor with 2 speed sensors, so we can measure the speed of the shaft and also the torsion. There is a load cell to measure the torque of the motor, and an accelerometer here to see the vibrations on the plate. This is for the mechanical power, while for the electrical power we measure the current and voltages on the 3 phases and on the DC. While we have some other important measurements in the lower bay. This is a compressed air tank. We measure the pressure with a pressure sensor and the strain with a strain gauge. And finally, this is the custom-made smoke machine that we designed, which is basically a big electronic cigarette, and we measure the temperature that the heater reaches.
And this is the compressor for the...
Correct. Yeah, this is the portable compressor for compressed air. We can reach up to 7 bar. This is the 3D printed liquid tank for the smoke machine, and we have a speaker and LEDs to simulate the flight. And the cool feature is that we can remove the upper bay, just sliding it out, removing just 3 screws, and so that this works as a standalone system to make power measurements, so that you don't need to bring everything with you when you're to the customers. And I also want to thank all the develop for the support that they gave us. So I want to call Riccardo with us to thank them, so Riccardo, Viorel, Daniele, because it would have been not possible to do something like that without them. Thank you.
It's been a pleasure.
One last question I have, is the compressed air used to push out the smoke?
Yeah, also basically at the moment of the startup of the engine, we can push some more smoke out of the fake combustion chamber that we have here below, but the smoke comes out also without the support of compressed air. So it's just to have an extra boost.
With the way you're doing measurement systems and what you're interested in, me, when I was at Tesla, I had these coins created for my team. There's only 50 of them created a year. Last year, this is the last one I have. And this one here is to make you an honorary member of my Tesla instrumentation team. Even though I'm not there anymore, I still have a lot of friends that are there, and I think you have an amazing future.
Thank you. This is a 3D printed. This is a 3D printed box. Sounds like a DeWeSoft product.
Yes, we made this to like a series, so to give it the same design of DeWeSoft and the logo of DeWeSoft and for motion series together. And you have here some analog outputs and a CAN bus output that interface on DeWeSoft measurement stuff.
And so you make these simulators for racing cars?
Yes, this is for racing cars. We sell them on usually to real drivers. Our other are the simulator centers, where they have many of them, and they use them to teach drivers new tracks or to improve your driving ability.
So this is supposed to be quite realistic?
Yes.
And you're measuring all the different parts of it with the series.
Yes, this is series. I think this is R2DB. This is an integrated system with a computer and series.
And there is another computer there. Is it to run?
The computer there is for the simulator.
The graphics, I
Yes, graphics and all that. So and the movement from the simulator. And then we have an output on a USB that communicate all the data from the simulator through these analog outputs like sensor to simulate sensor, real, so to can teach test engineers to set up a configuration and drivers to make the test in the right way. So this is a teaching platform for new drivers and new engineers that want to measure or do some new tests and so on. And in real life, my work is to measure on prototypes all this performance or temperatures, vibrations, all the performance of the car. Lap time also, because we made the record on Nürburgring with Lamborghini, Aventador, SVJ, and so on. So our work is very big stuff. So we make any kind of a measurement on the car. So we can adjust the distance from here. Take your hands on the wheel. Okay, we can. Okay, perfect.
My feet go here.
And now, okay. Push the gas one moment, please. So to say, okay, perfect. Okay, so you can drive, reverse. Okay, you need to do first gear and then
okay.
Okay.
I think they might.
You can go down. You need to go right, out from the box. Be careful. There, right. Not left.
I thought it would be harder. I thought it would be harder. And what if you crash? What will the simulator do?
You feel the bump. Yes.
Yeah, it does.
But it's limited because for safety.
Yeah, you don't want to fly.
Yeah, do don't fly.
And break.
Exactly.
So what is this setup you have here?
What we do here is wireless technology. So we are the producer of this toy, which is a fantastic toy. This one here is an amplifier for measuring the deformation through the strain gauge. What this guy does, in contrast to the others, is powered by induction, electromagnetic induction, and then sends the signal back via radio frequency. So here you can see...
Wait, how is it powered? There is a coil here, and there is a magnet somewhere here.
No, there is no magnet. So there is a coil here. The primary coil is here inside, and we have a secondary coil here inside, outside. It's like a transformer. We have the primary coil and secondary coil. This is the real business. So you get the power from the coil to this amplifier, and the amplifier then condition the strain gauge. And then it gets the signal back, and then it's sent by a radio frequency to this receiver, and then all the way back digital to this one, which is called the make unit. And from the make unit on, we go with the analog input into the series.
Okay.
And here you can see we have a setup. We're controlling with the series here. We're controlling the driver of the engine. We have a brushless engine here.
Brushless DC motor?
Yeah, exactly. Motor, correct, sorry. And here we have this wave. And now I'm going to power up the system, and now it's going to speed up. So we have this signal, this one here, which is the driver control. And this up here is the torque, which has been measured by the strain gauge.
Okay.
Then, if you want to try yourself, now you can try to apply some torque and then see what happens here.
Seems to be quite sensitive.
It is. It is.
Oh, what kind of unit is this?
Sorry?
What unit is this?
It's Newton meters.
Newton meters of torque. Okay. So, why is it at 13.45 now?
Because it hasn't been nulled. So you can do here in DeWeSoft, try and set up. You can go on the setup, and then you see 0. You second zero signal, and has been zeroed here, and now it's zero.
Okay. So if
Crank gauge installation is quite sensible to the zero. It doesn't like zero very much, but it wasn't to zero before.
This is a setup where this is the reader, RFID UHF reader. So we are communicating, the telemetry is at 900 megahertz. This is connected to two antennas that are above the battery module, and there are sensors inside the battery module over the bus bars, so over a metal surface, that are measuring the temperature and provide the data wireless that are collected by this device. This device is then connected to via Ethernet and can communicate via with DEWESoft TEXYS. And we are prepared an interface where you can see the sensors over the bus bars inside the battery module with different kind of visualization interface. This is a real-time monitoring of the temperature. Ideally, with this kind of technology, we can monitor the temperature of every single cell of the battery pack. With only two antennas, so only two cables, we can monitor hundreds of sensors, so hundreds of channels.
And why two antennas and not one? So
two antennas to provide a correct area coverage, a robust area coverage of communication. We can use two antennas, up to 4 antennas for this device, but in theory we can use all the interrogating antennas that are needed to cover the area you would like to read. So it depends from the scenario. This is a scenario of the battery module, but we can monitor also very large infrastructure, such as industry, chemical industry, switch gears inside electrical equipment inside switch gears. So also over large area, we can use hundreds of sensors and only few antennas for gathering the data.
So at the end, you have a big area of cable. With this, you can have one sensor, etc. So let's say on one channel, you have 10 to 20 sensors, and you have 8 channels.
So if you have one channel, you have two channels. Because how can you tell like which one is a percent? I mean, if you know the total, then you know the total temperature. How do you know whether it's 50 or whether it's 20?
There is a calibration at the beginning. So there is, first of all, what we say here, there is a FDG. So there is a physical modification of the fiber. And we know that at this distance, there is an FDG. So it's inside the software.
So basically sends a push report, and then it sees that the signal which came back after 10 seconds.
And when it sends another line, if there is a temperature increase, the sensor, the wavelengths will have moved. For example, here at 20 degrees, the wavelength is here, 1541.368 nanometer. If I increase the temperature, then it will move to 1541.43. Okay? And then the interrogator will find of the lines, and when they will get the response, here there is 5 degrees of difference because it takes more time to receive. Okay?
Is it you can get higher sample rates with this technology?
Because we are doing monitoring of a big structure, so temperature or strain is going very steady.
So because you simply don't need like 50 megahertz.
No, for some application in aerospace industry, when they want to measure burst of temperature during the launch of the rocket, sometimes there is a very fast temperature modification. In that case, they need high frequency. But there is few applications where frequency. And then you have the DeWeSoft software plugin which operates with our system.
So you use OpenDaq also?
We are open to it.
So this is the new DC-CT sensor. So what's special about it?
Yeah, the main features for this sensor is its miniature size to capture the currents in ranges of up to 1000 amps. It's a remarkable bandwidth of up to 500 kilohertz, and also the lower power consumption in comparison to the other zero flux transducer. That makes it very suitable for the in-vehicle current measurements, so in e-mobility, as well as to the regular power applications like network grid, power quality analysis, small and high current amplitudes of different applications.
So this has an accuracy of about plus or minus 0.02%. But can I in DeWeSoft X put a range of like 100 amps so that I have a plus or minus of 0.02 amperes? In a 1000 amp range,
yes,
it has a plus or minus of 200 milliamps.
Yes.
If I set the range to 100 amperes,
yes,
I should be able to measure with the plus or minus.
Okay, yeah. The thing that we are discussing here, the accuracy of the sensor itself. So these calculations that we provide are the accuracy of the sensor. However, if you connect this to the host amplifier, to the host device, this can then also add the accuracy of that host amplifier to it. In order to make the most optimal value of the range of the host amplifier, this is then the best way to, let's say, optimize the accuracy of the whole chain. So sensor plus the readout data acquisition system.
Yeah. And to power it, we need this power supply here.
Yes, so it works with a plus minus 15 volts excitation sensor supply, but we provide, as a DeWeSoft, provide the power MCTS, so the power supply for 4 sensors, mainly for the applications like DC plus 3-phase measurement, so it fits perfectly for the powertrain analysis to capture the 4 currents at once. And then from that power supply, the signal is routed to the host amplifier.
Yeah, because the single series is too weak to power one of these.
Yes, exactly. So the maximum excitation from the, for instance, low voltage channel is 2 watts, but this is a 5 watt, approximately 5 watt power consumption of this sensor.
Okay. And so having this is the only way to power it?
No, I mean, you can power it from the otherwise. So it's this is just the convenient, let's say, suitable system where it's easy to connect or easy to use, and we provide it as a whole solution. But it doesn't have to be particularly this power supply. So you can power it directly from it. Actually, we are even working on a solution that will be able to power and acquire then the analog data from the sensor at once.
Interesting. So you would want to make like an upgrade to the series so that it has a more powerful power supply?
Actually, it has a, let's say, a trade-off. So in that case, series is still intended for the high bandwidth measurements. So for the, especially with the XHS, where we can reach the 5 megahertz bandwidth with the analog input. That particular is intended for the high power supply option for the sensor. Yes.
Okay. What is your role in DeWeSoft?
Well, Etto, like all roles in DeWeSoft, it's quite interesting, and every person wears a few hats. Imagine a human interface connecting global teams throughout the world with the headquarters, which is located in Slovenia and is the center of the research and development, management, and the support services, and of course production. We have organized 20 sales through 20 subsidiaries and over 50 partner companies worldwide. So information flow is important. And our main goal and OKRs of every year is to support the sales team there to boost their sales activities. But not only that. We also work hard on the educational portfolio and establishing more and more connections through European faculties, universities, and even colleges and high schools in Slovenia.
So part of your job is trying to contact schools.
Yes. Not just to contact, it's not like cold calling, but during our activities, you know, things usually just click into the place. Many of very renowned engineers are also simultaneously external or how would you say, employed professors at certain faculties within universities, and of course we also collaborate with them because we gain a lot of requests to upgrade or to replace obsolete equipment within their test laboratories. So the STEM study fields are very interesting for us because we also work with the professors and engineers that are employed there. And through that, then naturally, any student events and projects evolve. We have also students contacting us directly through different subsidiaries or headquarters, requesting rental demo equipment for their master thesis or even PhD thesis. So, and this is where magic then happens, because it's all about the community and people connecting. As you know yourself, test and measurement field of work industry is quite niche. And today we've managed to gather over 500 experts from this segment, which are usually not just customers, they're also partners. There's a large exhibition area, and I would dare to say they're basically our users, our basic, asset of the company.
If I may add a few words, there will be a presentation of the new Idle One rocket here outside at 10 a.m. If you want to pass by, you'll see some smoke.
A little bit what you're talking. Yeah, so basically this is a demo toy that me and some colleagues of mine did for DeWeSoft with the help of the Italian team. So we can take 15 measurements with it, basically. So we have an electric motor. We can make both mechanical power measurements and electrical power measurements. We measure the speed of the shaft with this to, yeah.
When I saw the picture, I wondered. More or less okay, but this one I didn't understand what it has to do in the rocket.
It's to show off. So basically we measure the speed of the shaft in 2 points. So when you apply brake pressure, you can see the torsion on the shaft because the two discs misalign. We have a load cell here to measure the torque, an accelerometer to see the vibrations on the plate that you can see there, and this is for the power, for the mechanical power. For the electrical power, we take the currents and voltages on the 3 shunts for the AC and on the DC as well. And the upper bay can be removed basically and can work as a standalone system because it has its own battery and its own electronics. And you can just slide it out, unscrew 3 screws, and you can use it as you prefer. And then the lower part, we can take some other measurements. This is a compressed air tank that we load with this portable compressor. And there is a pressure transducer here, and also a strain gauge to see the deformation of the tank. And also this is a custom-made smoke machine, 300 watts heater that we power with this 50 volt battery from an electric scooter. Basically that's it. This is the plastic tank. Oh yeah, this is the misalignment of the disc. So when you brake, you can see that it changes. Mechanical power. basically. Yeah.
But unfortunately, this has just 3 holes. So you see the torque there is too.
This disc has only 3 holes.
Yeah, we need to be the more higher resolution. Otherwise, you get less. It will be modified.
So those are all the measurements. Here we have a pump for the liquid, some volts, and a speaker to reproduce the sound of a rocket, and also.
Shit, you know, I got yesterday from French Guiana the USB stick with the audio of the Vulcan.
Oh, you have to give it to us. Please send it.
Now we have the audio from a rocket that we built last year. Because
is this the same size of the rocket you built or same proportion?
It's similar because I used to work in a rocketry team in the university. So the last rocket that we designed, it was bigger than this one, 150 millimeter in diameter and 3.7 meter long. This is more similar to the previous one that was around 2 meters high. So basically similar size, and so we can see the temperature of the smoke machine, the pressure. Basically simple commands that you can send over Wi-Fi. There is the electronic board is behind this, and all the connections are done with spring-loaded pins, so that you can just slide the upper part out. So the temperature now is
getting good, or not?
Yeah, because there is a thermal switch here that basically stops the heating when you reach 300 degrees, and then it powers it on again when you reach around this temperature. So this is the minimum allowed, and now you should raise it up again so that we have more smoke. Everything is measured, of course, by DEWESoft. So there are just 4 these sub connectors here, and you can use it, as I said, you can use it on battery, or also you can keep it under charge while you use it, so that it has virtually unlimited life. Now it is getting again the temperature up, and now it is counting down.
And now the alarm system will stop, yeah?
Hope not.
You have to imagine this in an exhibition, in a booth, maybe twice a day. You create the panic there. That's the purpose. That's it.
Cool, great. Congratulations.
Thank you so much.
Great engineering.
Everything that goes down kind of bounces back at your spot on the other surfaces. So then the probe, I just need to watch that I place it perpendicular to the surface. Starting at the front, I place it at the approximate center of the upper left segment, trigger the measurement with the button.
So here you have this shaker, and these cubes, I don't think these are sensors.
No, these aren't sensors. These are just stress relievers, but they're like our sensors. So this is a shaker here, so you can control the force and frequency input into your test structure. So this is a slip table, you can mount products to it. You can rotate that vertically and test products on it. So PCB, we have shakers, and then we have the sensors for measuring as well.
Yeah, and so these are your sensors. You have some microphones here.
Yep, so microphones for acoustics. We have pressure sensors, very high frequency pressure testing, so both piezoresistive, piezoelectric, and then we have full range of vibration sensors, force sensors, again, MEMS and piezoelectric. And how you use those just depends on what application you're testing on. So low frequency use MEMS, high frequency use piezoelectric or piezoresistive.
So for example, this shaker, you use it to put the product on, and you can put different accelerometers on it so that you can see how it responds to different.
Correct. You're really looking for vibration modes, so how that structure is behaving across the full frequency range, from very low frequency to very high frequency. Structures will have their own resonances. You try to design products to avoid those resonances and account for those resonances to improve performance and avoid product failures.
Yeah. And what do you have these stress reliever cubes?
These are just fun, but on very, very large test structures, when we're testing satellites or we're testing aircraft, you can actually mount these on your test structure, and everyone can follow this cube for alignment. So to make sure everyone is following the same axes of orientation for all your instrumentation, make sure X, Y, and Z are all orientated correctly when testing.
Okay, so this is one of your cameras which you control with DeWesoft X.
Yeah, exactly. This is one of the Photon high-speed cameras. In that case, it's a Nova S16 color camera. And this camera is fully synchronized with the DeWesoft data acquisition device. And we can control the camera and the data acquisition device via the DeWesoft X software. And I can show this to you if you like. What we need to do, when you set up the test, obviously you need to set up your recorders first, your analog channels, digital channels, and so on. And as an additional device, we are choosing video. When the right DLL files from our side are in the DeWesoft folder, then we can activate the camera already.
Yeah, and it's connected via USB?
No, it's gigabit. So the camera itself can be controlled with Ethernet, either 1 gig or 10 gig.
Okay, gigabytes per second?
Sorry?
Gigabytes per second?
Gigabit per second, 10 gigabit or 1 gigabit per second. Yeah. And when you then have added the device, you can completely control the camera in the DeWesoft X software. I need to turn on the light, sorry. Now it will become very bright here, so don't look directly into it. So, okay, now you can look. It's just the first moment is a little bit of a surprise sometimes. And here we can set the frame rate of the camera. Right now we are operating the camera at 10,000 frames per second. And we can adjust the shutter speed. And we can set the trigger mode, so we can explain the software how many frames we want to record in advance and after the trigger. Yeah.
Like there's written that you are up to 8,000 FPS?
This is a different camera model, so I think that I will overdo if I now explain all our cameras. In theory, we have from these Nova models two standards. This is the S, means speed, and this is the R model, means resolution. So these are high resolution models with a lower frame rate. These are 1 megapixel models with a very high frame rate. This camera can record up to 1,100,000 frames per second, and these cameras only 200,000, something like that. But this camera only has 1 megapixel, this camera has 9 megapixels.
Okay, so these are some displacement sensors, and you want to see how the two plates move apart?
Yes, exactly. Basically, we normally used to deal with the market of the automotive market and the aerospace, but specifically for this event and for this exhibition, we decide to show some more civil engineering oriented applications. So there is a crack, like simulating a crack on a wall, and we are trying to catch the displacement of this crack to avoid any more damage on the civil structure or civilian person.
Yeah, so if we move this, then we see a movement on the graph.
Yes, exactly. It's directly the information is sent to a digital converter, sent through the USB and sent after on the DeWesoft. Without plugins.
What acquisition system are you using from DeWesoft?
It's a plugin made by the DeWesoft team, specifically for these probes.
Oh, so it's directly connected with USB.
And we also have some non-contact solution because from time to time we cannot make some link directly between the measurement part and the mobile part. So we also have some triangulation laser.
And how accurate are these? How small of a movement can you measure?
It's below the micron. Below a micron millimeter. So this probe has a 0.5 micron of accuracy. No, 0.5 micron.
So if I push these plates a bit together, it should see it?
Yes. You could even simulate a kind of seismic an earthquake, for example, and it will catch it.
So Etto, tell me a little bit about some of the power electronics studies that you're doing. I saw you build a Tesla coil not too long ago.
Yes, I did build a Tesla coil, and I also tried to make a circuit for the DeWesoft Italia. So there I made some power electronics, I made a stereo exciter circuit, and I measured it with the series HS, and I had a whole effect current now. And I should be able to get one of these DCCTs in the near future.
Perfect. Did you look at some of the power quality happy from your Tesla coil, or did you play around with any of those metrics in DeWeSoft?
I did not have much control over the Tesla coil, really, as I also didn't have that much time to optimize it as much as I would have liked.
Okay, okay. Are you going to get into like motor analysis and things like this coming up?
I did one test of an induction motor, and I found that interesting. Actually, I also measured some things about the universal motor, which I took from a washing machine.
Okay.
Yeah, probably the induction motor was one of my favorite tests I made. I measured temperature, acceleration, sound, voltage at mains, at the structure of the motor, and at the rotor.
Sounds like you should go take a job at Whirlpool or one of the appliance manufacturers after that. What's the next big plan for the great Etto Finns on the Power Quest?
The great Etto. Well, so I'm always trying to make a more powerful CPS, something I've always wanted to do, and more powerful Tesla coil, that's for sure. And those are probably the things I'll focus on.
Pardon?
A more powerful Tesla coil.
Oh, okay.
And a more powerful CPS.
Very fun, very fun.
Because I have this CPS which I use for driving transformers, high voltage, high current. And if I make it more powerful, maybe I can do magnetic levitation.
Well, then you're going to have a lot of other components, like you're going to have to build your own DC to DC converters and things like that. Or do you get into the power conversion side at all? Have you played around in that market?
Yeah, I did. I can use the CVS, it's a DC-AC converter.
Okay.
So if I use a transformer and a rectifier, then it becomes a DC-DC converter.
Very
For example, I've used it to charge a capacitor bank from 12 volts to about 200 volts DC.
Very cool.
And also do higher currents, so from like 30 volts DC to 2 volts DC. Much higher current.
That's very interesting. Well, are you enjoying the measurement conference so far?
Yes, it's quite interesting to see all the stands and all the sessions. So yeah, it's quite interesting.
Well, thanks for coming. We really appreciate you being here, and feel free to go ask anybody any questions, because you are our mascot here at DeWeSoft. So
thank you.
Welcome to the club.
Thank you.